The last conic section that we'll be talking about is a hyperbola. With this, a hyperbola is similar to a parabola and similar to an ellipse equation. With a hyperbola, it looks like two parabolas. And it could go on the y, or it could go horizontally as well on the x. By definition, though, a hyperbola is a set of all points such that the absolute value of the distance of the difference of the distances from any point to two given points called the foci is constant. All right, and so that's similar to, it is really similar to an ellipse. Remember, an ellipse is a set of all points in a plane such that the sum of the distance from the foci is constant, where a hyperbola, it's the difference. So when we're looking at an ellipse is addition, where a hyperbola is subtraction. And you can see the difference with this standard equation of our hyperbolas. And that also gives us a better understanding of the two. So with this, I'm going to leave this picture up here and we're going to talk about some of the different things. With the hyperbola, you actually have two asymptote lines. Okay, so you have an asymptote line that goes here and here. So notice it matches up with both curves. You're going to have some foci points, or some focus points, but plural. The foci will go F1 and F2. You're also going to have your vertex. This is the center. You will have two vertices, and that's because obviously you've got two different curves going on there. So before we had talked about the horizontal major and a vertical major. It's a little bit different with the hyperbola. You have what is called the transverse and the conjugate. The transverse axis holds the vertex and the foci. Holds vertices, it's plural. And conjugate axis is with B. So this is perpendicular to the transverse. And is 2 times B in length. So we haven't talked about the A and the B yet. With this, your A length is from your vertice to the origin. So this length here is A. From the origin to your focus at C, and I shouldn't say origin, it's to your center. Our center happens to be at 0, 0. So A is from your center to vertice and to a vertex, and your C is from your center to your one of your foci point. And your B, this is a distance that goes from here to here. This is your B, and that's your conjugate axis. Okay, so let's actually look at the true equations here and what we kind of know. So in true form, if you have a transverse axis, if you have a horizontal one versus vertical. It's got another little chart. So if you have a horizontal one, the A is going to be underneath the X. So this is similar to the ellipse in which you have the A value, which is normally your larger value, underneath the X. So here's the difference between an ellipse and a hyperbola. An ellipse, remember, we added in between. With a hyperbola, we subtract. So then we have, with a vertical, it just shifts a little bit. And that the B squared, ooh, I'm wrong here, doesn't shift. The A and the B stay the same. It's the Y and the K that, or the Y and the X that shift. Sorry, my fault. And the reason why you can't shift those, silly me, is because you're subtracting. So the larger A value has to be connected with the left side because that's the larger value. If we were adding, we would have that switch, but because we aren't adding, we are subtracting, we need to have that switch. Our center is still at H comma K for both of these. Notice again, it switches signs, don't forget that. The other thing is your asymptote lines. So because there's two, you're going to have a plus minus. And that just gives you the negative slope and the positive slope. With the vertical, the A and the B just switch. It's not necessarily that the Y and the X switch. And the other thing is, how do you find your equation? Well, we need to talk about your foci and how to find the A and the B and the C. Your foci are still dealing with the H and the K, and that you have your plus minus C, which is still what we knew before. However, to find your A, B, and C, it is a little bit different. And this is technically for both here. It's C squared equals A squared plus B squared. So we haven't actually gone through an equation yet, and that's our final step here. There will be times when you need to go through and do your completing the square. let's say, for instance, I have y plus 6 squared over 20 minus x minus 1 squared over 25 equals 1. So right away, we know that the y is first, therefore we have a vertical. So now we're just going to go through our information, our little chart there, and we're going to write everything out. The first thing I'm actually going to do, though, before I start with the chart, is I am going to find the a, the b, and the c. So right away, a squared is always first. So we have a squared equals 20. Therefore, a is going to equal 2 square root 5. B squared is 25. B is then going to be 5. Remember, it's c squared equals a squared plus b squared. C squared, therefore, equals 25 plus 20 gives me 45. I need to simplify that, though. C is going to be 3 square root 5. So now I'm going to go through my chart and fill everything out. Now that I've got the A, B, and C, so my center is at H comma K, which is going to be 1 comma negative 6. My asymptote lines, so this one, remember, is going to be in the form of A over BX, which is going to give me y equals plus or minus. I have 2 square root 5 over 5 x as my asymptote lines. I already know that this is vertical, and I need to find my foci. So because it's vertical, it goes with the negative 6 and not the 1. So I've got 1 comma negative 6 plus or minus 3 square root 5 as my foci. And I forgot the most important one, your vertices, which I forgot to put in the chart. I am sorry, this is my fault, not my day on this one. This one, because you're dealing with your transverse axis, with your foci, it's negative 6 plus or minus c. With the vertices, it's still h comma k, but the plus or minus is of the a value because the a is dealing with your transverse axis. So we've got 1 comma negative 6 plus or minus 2 square root 5. So that's where our vertices would then be located. So really not that much different than what our foci points were. And you can see going back on this, you know, our a value was to our vertices. So you might want to write that additional vertices on the chart. Actually, we'll just do that now. Not quite to my 15-minute limit yet. Which, again, really did not change a whole lot.